Good morning, ladies and gentlemen. This is Mr. Allen here, and we are starting on our next unit, which is logic. I think a lot of you guys will like this because there's no math in it. It's all about words and language and manipulating that sort of thing. So, without further ado, let's get into it. We're starting off, we'll be talking about conditional statements and some of the ideas surrounding them. So, first off, inductive reasoning is reasoning based on patterns. So, for example, I say the Redskins lost in week 1, the Redskins lost in week 2. I see a pattern here. The Redskins are probably going to lose in week 3. My conjecture is the conclusion that I reach using inductive reasoning. My conclusion is, all right, I think the Redskins are going to lose this Sunday, and it makes me sad. Now, obviously, with inductive reasoning, you don't always get accurate predictions. And in fact, a counterexample is an example that shows that a conjecture is false. So if the Redskins do, in fact, win, then you'll be able to have a counterexample for me on that particular conjecture. So let's take a look at this first one. So if the name of a month starts with the letter J, it's a summer month. Okay, so January would be our counterexample, right? June and July are the ones that we think of that fit the pattern, but since it starts with the letter J, but it is not a summer month, then January would be our counterexample. You can try these other two on your own. I'm not going to go through and do all of them, but use some creativity. Next, when we talk about negation. So negation is basically making the statement the opposite of what it is. And when we are writing that in symbolic form, we use that little squiggly line. We call it a tilde. Just that little whoop. It's the same symbol that's on top of the congruent sign, which is a little confusing, but don't worry about it. So the negation of I am going, I am not going. So that's pretty easy enough. Now, where some people get tripped up is that if your sentence is already a negative, then the negation of that would be to take out the negative. So you would say, I am going, or I am awake in this case. Okay, cool. We shall move along. Now, a conditional statement has two parts, and you use these all the time when you're just speaking. So things like if you don't stop talking, I will smack you with a flamingo. That would be a conditional statement. It has a hypothesis, which is an if, and it also has a conclusion, which is the then part. If hypothesis, then conclusion. And we would do that with a symbol P and a symbol Q respectively. And that little arrow over there shows the directionality. It shows that we're doing if P, then Q. Let's move along just a tiny bit. Just a second. We're going to switch our colors. All right. So I would say that when you're trying to parse out what is the hypothesis, what's the conclusion, just put that little X through the if and then underline what comes next. So it is noon in Virginia. That would be our hypothesis. And we would do the same thing for then. Then it is 9 a.m. in California. So our conclusion would be it is 9 a.m. in California. It's the clause or the statement that's immediately after the then portion. Okay. Gonna let you try example 2 for just a second. So pause the video and try this. Yep, hypothesis is if, and the conclusion is then. Just take a second to try that. So, if an angle measures more than 90 and less than 180. So, it looks like this is kind of a clunky thing to be our whole hypothesis or our whole conclusion. But we're basically going between the if and the comma. Whereas with then, we go from the then to the punctuation. So whether it's a comma or a period, usually you're going to have some sort of punctuation that's going to clarify that for you. So if a student is taking geometry, then they have math during an even block. So that's just a little reading strategy you can use to help. Now, sometimes things aren't going to be exactly in if-then form, which makes it a little bit tricky. So you'll have to try to rely on your common sense, because sometimes the if is in the middle. So I might say, I will smack you with a flamingo if you don't stop talking. And in that case, the order of our if and our then, of our hypothesis and conclusion, is reversed. So you would say, so if 2 points lie on the same line. So see, the lie on the same line part is our hypothesis. But then we would say, then they are collinear. Now, it's tempting to just do it word for word and say, if they lie on the same line, then 2 points are collinear. And sometimes that's not wrong, but it's oftentimes just easier to rephrase it so that it makes sense. All right, now what do we do with B, with all fish swim? Okay, so the swim part, so that's going to be our conclusion, and the all fish is our hypothesis. So if it is a fish, then it swims. That's another way to say that all fish swim. All right, we're going to move along just a little bit, scroll ourselves down. We'll skip C. You can just try that one on your own. Now, sometimes we want to rearrange our sentences. So when we have the converse, so the converse is Q. There is if Q then P. And you know the original is if P then Q. So you can think about the CO in converse as change order. Let's take a look at an example. If it is my geometry textbook, then it is blue. So the P would be, and the P in the original would be if it's my geometry textbook, and the Q in the original would be then it is blue. So we're going to switch that around. So if it is blue, then it is my geometry textbook. Okay. Now the inverse, moving down here to the inverse. Take a second to adjust. And something that's important to realize about the converse is that look at your statement. Does that even make any sense? If a book is blue, then it's my geometry textbook. Well, no, of course not. There are lots of blue books that wouldn't be your geometry textbook, even if your geometry textbook is blue. Let's take a look at the inverse. So the inverse, we would write it like this. If not P, then not Q. Okay? Not Q. So remember by IN, insert not, or just negate. Two ways to do it. Okay. So let's look at our original. If it's raining, then practice is canceled. Okay, makes sense. You wouldn't want to practice whatever it is in the rain. But let's check out our inverse. So if it is not raining, then practice is not canceled. And again, let's think about whether or not this makes any sense. Is it possible that we would have a scenario where practice might be canceled and yet it is not raining? Well, what if there were an earthquake or locusts? So yeah, that's not true. If there was an earthquake, then we might still have, it might not be raining, but practice might be canceled anyway. So let's look at contrapositive. So contrapositive is, first of all, it's always true. Okay. And you'll see why in just a minute. But let's take a look at this. So the conditional statement is, again, if P then Q. So this one is a combination of the inverse and converse. So we would say, if not Q, then not P. And you remember it by the con and contrapositive. So you change the order and you negate it. Change order and you negate. Not too bad. And let's just take a quick look at our example. So if we are in Virginia, then we are not in Texas. And again, it's helpful to remember to underline and circle all this stuff along with the notes. So let's take a look at how we would write this. So if we are in Texas, because remember we're negating it, so we're taking away that not, then we are not in Virginia. Again, negating it. We are not in Virginia. In VA. And that is all, folks. So thanks for watching. Enjoy the rest of your day. Bye.